Hi, everyone, and welcome to another segment for Mock Interview with Exponent. Today, I am here with Sam. Would you like to introduce yourself, Sam?
Yeah, sure. So, as I said, I'm Sam. I'm a senior TPM at Amazon. I specialize in communications and also just stakeholder engagement in general. So, a bit of a people's person. I started off as a software engineer and then kind of made my way up to like a team lead, program manager, and then like IT team lead, program manager esque, and then going more into the manager role. But I always have that software engineering itch that I want to scratch. So happy to be here.
We're happy to have you. My question for you today, I would like you to design Ticketmaster, bad PR notwithstanding.
Okay. Awesome. Okay. So before I go into it, I guess I wanted to get some clarifying questions
Okay.
before I get started. So we're essentially talking about a ticket reservation system as Ticketmaster is. You're able to go on, view events, and
hmm
then whatever events are available, go in and pick seats for the events depending on which day and time the event actually is. So for this one, how many events are we selling tickets for? Would you like us to like maybe have a reasonable estimate for it
Yeah,
so
let's
we
come
can?
up with an estimate for what we're dealing with.
Okay, cool. And well, just following that trail of thought, it would just depend on which event that we do go to. So uh, maybe we can see if we can look at two types of events, like a relatively small event and then a
hmm
bigger event. So small events would have like at the most maybe 1,000 tickets, and a bigger event would have go up to 50,000, just to be on the you know relatively safe side. Okay,
Okay. Yeah.
cool. And then, uh, well, users, when you come in and you think of Ticketmaster, you either have the option of actually creating a profile or just, buying the tickets as a guest. So maybe it'd be good to have an option for users to do that because we don't want to force them to actually create a user profile if they don't want to. So I think that would be important. Cool. And then I guess at the end, I think for looking at this, one thing I really want to focus on is the purchasing side. There are a couple of scenarios in which I think we may need to tackle, especially if we have a relatively big system like this, which we'll
hmm
encounter. So it'd be good to do that. So I'll share my screen and then just kind of write down those functional
Sure.
requirements that we just. So right now, just want to look at the um, functional requirements. And so we're going to be creating a scalable ticket reservation system, right? Where I guess the users can, let's see, so they'll be able to, we said, browse events and then select, seats based on the events. And then obviously you want them to buy the seats. And then finally, I think we said we're going to give them the option to like make a user profile, and that would be important. Just moving on, because if users want to come back again and re buy more tickets, like if we have the option for them to store payment info, that
Yeah.
would come in handy so that they don't have to keep typing in their info for that. So cool. This looks good. I would like to move on to the API endpoints for a
I think
system
that
like
sounds
this.
good. Yeah.
Okay. So let's see. Well, obviously the main thing here is events. So what we want to do is have a event API endpoint, which would kind of get the list of available you know events which are currently available.
Okay.
Um, so I'm gonna do this for like okay, get list of avail spell right events. Um, and then okay, so if we're gonna be doing that, we need something to oops, we need something to get the event details. So that's gonna be taking in some sort of event ID, and then that ID can give us the details of the specific
Hmm.
event. And then, well, you said we also need to reserve available seats. So this endpoint would just get the available seats, and that will take in the event ID, and that would go to the like, seats as well to get
And is
that.
this event ID different for every instance of a larger event, or is it for the, like, let's say there's a comedy show, is it a different ID for like the Saturday night show, the Sunday show, or is it for the whole instance?
Oh, I see. Yeah. So in this case, it'll probably be for like depending on how we do the specific database later on.
Hmm.
So
Hmm.
this event ID would most likely be for like a main one, and then if the data is sharded into specific events based on dates, so, that could be a thing later
Got it.
on. Yeah,
Okay.
cool. And then once they've picked the event, we want to reserve. Oh, event and ID. We want to just reserve the seat of the event. Uh, well, so seats, and then that would also have a seat ID, which we can then reserve. Cool. And then if we go on and we want to give them the option to register and log in, that would be a endpoint. I'm still getting used to whimsical, but it would be a post HTTP method where users would be allowed to register with their own information.
Hmm.
Um, and then you can extend that to like login stuff. But I just want to cover the basics right now. So just moving on
Okay.
to purchases, and that would also be opposed to post the purchase record or create a purchase record of when a user buys a seat for a specific event. And then, you could
Okay.
go in further to see if you can, check the history of the previous events that
Yeah.
they got. Okay, cool. So looks like we have that. It's great. And I ideally, I think now would be a good time to actually kind of estimate the system size. So if we if we do that real quick, we're just going to do that simply by breaking down what the questions. So first question would be the how many events, right? And I look at something a similar ticket reservation system like AMC or even
Hmm.
Ticketmaster. What they'll users are usually allowed to buy the tickets like 3 months in advance, right?
Mm.
So if we assume that, and this is just an assumption, like on any given day there are 200 events, then what we can do is with the that first assumption of the buying the tickets 3 months in advance, uh, we can then actually just um, calculate uh, on average like how many events there'll be. So we'll do 200 events multiplied by 30 days a month, and then multiply that by 3 months, which gives about 18,000 events. But just to be on the safe side, we're just going to make that just for make the calculations a little easier. 20,000 events that we have, and so now we have like
Over a 3 month period
yeah over
worldwide. Okay,
yeah. Oh, yeah. Maybe I should have clarified that before. This Yeah. So any given day, um, if we yeah, I was actually looking at probably numbers within like the US, but if we do it worldwide, those would be great. So I just want to get like
that's fine. We can. I think you can limit it to the U.S. for now. I think that's fine.
okay,
Yeah,
cool. So
yeah.
we have the events, and then we think of how many tickets for each event. And when we spoke earlier, we had mentioned that there were going to be two types of events, right? A relatively small event, which would have, um, you know, probably a max of 1,000 tickets per event, and then a big event, which would have essentially like 20, or we said 50,000 tickets. Now, obviously, the number of small events are going to outweigh the number of big events. So let's say out of all the events, a quarter of them are relatively big events. So that's, your really high end famous, like if it's a concert, famous person coming in, say Swifty or Beyonce coming in, those would be a relatively big event. And what we can do here is now just calculate if a quarter of these 20,000 events are big, then we would have essentially that 50,000 tickets multiplied by the 5,000 events, which comes from the 20,000 being the quarter of the 20,000. So we have it's like 15, oh, not 15, it's 20, yeah. 25 10 to 7 tickets. And then for the bigger one, that's going to be 15,000.
Can we just break down that last calculation that you did? What is the 25? What's the 10? And what's the 7?
Yeah, sure. So this came from, we have 50 tickets that are for one big event. And then we know that in total we have 20,000 tickets. I mean, 20,000 events, and a quarter of those
Okay.
events are big. So then we would multiply
Okay.
the 50,000 tickets by the 5,000 events.
Got it. Okay. Sounds good.
Cool. And then similarly here, since that's 5,000, there's 15,000 tickets. Oh, 15,000 events that are big. So we would also just multiply, or small, sorry, 15,000 tickets that are small. So multiply the tickets and the events, which would give us in total about 15, 15 to 10 to the 6, yeah, 10 to the 6 tickets. So this is the amount that the system's kind of, tickets the system's kind of dealing with um, over the course of those 3 months.
Got it. Oh,
So
that's a power sign. That's why I was getting
yes,
confused. Okay,
yes,
got it. Yeah.
yeah,
Like, what are
okay,
we multiplying? Okay, got it.
yeah,
Okay, yeah, you're good. All right.
okay, cool. So looking at this, there's actually a couple of observations here. One, the larger events are way more tickets for the bigger events than the smaller events.
Mhm.
So I think for this use case, we might just focus on managing um, big event tickets.
Okay.
Okay, and so if we kind of break this down into days, if my math is correct, then what we would have is um, per day we're looking at around it's like 2 point something, but I think we'll just round it to 3 to the 6 tickets a day that the system's kind of dealing with. Actually, no, let's just make it 4, just for my safe. So it's gonna be four about yeah 4 million tickets a day that we're gonna just kind of deal with. And then the second thing we're gonna do is actually um, uh, the second thing would be checking the traffic. Um, Traffic won't be consistent. If you look now, for example, I don't think there's any major events going on, but last month, actually the past 2 months, Beyonce's been touring. I actually went to go see her, which was
Nice.
great
Lucky.
artist. Yeah, but you'll notice that those that traffic, like, it's a flood with those popular events.
Mm,
So we have to be mindful that out of these big events, there are some that are actually popular, and I'll say maybe a quarter are popular events, and they usually sell like I would say like under 10 minutes. So we just got to be mindful that as we go on, we need to um, be aware that that's they yeah that's like 1 million tickets that's been sold in under like 10 minutes, which is about
yeah.
you know 100,000 tickets a minute. So as we move on, just have to be mindful that um, that's a thing that we may need to um, keep and remember.
Yeah.
Cool. So now we've kind of have like an estimate of the system and the data that we may have. It might be good to look at the data schema for the database. So
Sounds good.
cool. So let's focus on that data schema. Um, First one would be we would have the events, right? And leave this. The events and uh, we'd have a I here I'm just thinking of the things that we would need. So obviously for an event you would it would need some sort of like unique ID, or like for this case this could be an oh, let me just primary key. And as I'm thinking, I'll probably come back to this again, but it's going to be a lot of this data would be relational, because if you think of
Hmm.
events, one event can have many seats, so it's a one to many relationships. So I'm thinking of also
Yeah.
having some foreign keys in here too, so that they can be connected. And then obviously we want the event date, and that could actually just be a timestamp. We got the event name, obviously. Then actually, let me just write all these down. So event venue and like some event description, and all these could be cars. If I want to be really specific, we could just make these 256, 6, and the description is a little longer, so maybe like 2048. And maybe if we have time, I can like we'll go specifically
Hmm.
into how many bytes like a an entry would actually be.
Yeah.
Um, we can just move on. Okay, can I do this? I'm curious if I can. Oh, nice. Okay, cool. So just following that, you would have the seat. So for seat, you have the seat ID, and that
Hmm.
also can be an int. And then I was just wondering too, because for seats, it's to make it sometimes easier. They have the seat sections,
Mm.
and also determine how much the specific ticket is
Yeah.
and stuff. So that could be an int. Here's a seat row, seat number,
Hmm.
and obviously we can't forget the seat price. Now,
Yeah.
additionally to this, may want to see if, like when it comes to purchasing, is if a seat is available. I'm brainstorming some stuff that we may need to change on this table,
Okay.
but for now, I think I'll just keep it as is, and then as we move on, might change that. So just
Okay.
correcting these right now. This would be an int. C number would be an int, and then here we have, seat price would be a double, and what we have would be if it's available, and that would be a boolean to check if the seat is like available or not. And then what we'd have here is an event ID. Oh, no, here what we have here is an event ID, which would be
Hmm.
that. Um, Allow me. Okay, that is interesting. It's not allowing me to put. Okay, well, what I'm trying to put in here is
Okay.
a int, which would be a foreign key to whatever event the seat is part
Yeah.
of. Right.
Okay.
Okay. And then let me see if I can put this. Okay. And then another one we can look at is the what we need to add is a user, obviously. So for a user, we need a user ID. A user would also have a name and a password, which would probably be like a SHA-256 hash, just for security purposes.
Yeah. And we're saying that they users do have to have a profile before they, or an account rather, before they start buying tickets.
No, actually, that's a good point. So there are two options. One is like they can actually go ahead and make one. But in the
Hmm.
case that they don't, what we can do is what we can do is actually I was thinking of creating a second table, which would
Hmm.
be for purchases, and then that would hold a purchase user ID. Actually, let me create that and then kind of go into kind of
Okay.
answer that question.
Sure.
So, yep. Let me just do this. Sharp 256, and then right, and then actually this would just have the user uh, credit card number, and then user credit card, its expiration date, and then honestly, I won't do it for now. But what could happen is that just for security purpose, you can just separate the user and then the user card information in a separate table.
Hmm.
So they'll be
Yeah.
able to, well, just for security reasons. Okay, but to focus on what we were talking about, I think it is important if we did a purchase table.
Okay.
Because then what we can do is okay. Uh, Separating the purchase tables will allow two things. One would be allow users to refund tickets. It's a bit more flexible that way, and then users can purchase more than one seat. So the purchase ticket would have in here. If I can just do
Hmm.
this real quick. Um, yeah. So the purchase would have like a the user ID. So whoever bought the ticket, and that would just connect foreign key. And then purchase event ID as well.
Yeah.
And, okay. And then also a obviously the thing that purchase the seat ID. That would also be a foreign key. Yeah. So but so actually to answer your question, uh, how do we essentially handle purchases from people with no accounts, because that's the option that we're given. There are
Hmm.
two options. The first one is that we make when a user who isn't part of the system already buys or purchases a ticket,
Hmm.
we make purchase user ID null. Um, because they
Okay.
don't exist. The only caveat there is it's going to be hard when it comes to looking up the payment info of earlier purchases from that same user. For example, if they
Yeah.
want
Yeah.
to refund. So what we could do instead is that when a new entry is created, or a user makes a purchase, we assign a unique user ID to that user, but we leave
Hmm.
username and password blank. That way, payment info on purchase tickets can still be tracked by the same user.
Got it. And if the user wants to retrieve their tickets at a later date without having an account, what would they need to do to pull those up?
Oh, so if you think about the way it's done now, there's usually a let's see. There's usually like a ticket, like confirmation. So usually, like a user is sent a like confirmation of the ticket and
Okay.
what that ticket like number is, or stuff like that. So there could be an option
Okay.
where it's associated to the seat ID, and
Okay.
that can be used to just retrieve the previous
Got it.
payments. Yeah.
Okay. Yeah.
Okay.
Kind of
So
like how a flight ticket works.
yeah.
Yeah.
So essentially, what we have so far is the user goes to the site or the app, picks one of the listed events, and then picks an available seat in that event, and either logs in, enters the payment info, and confirms the purchase. And the seat is either marked sold, or you know, and then the payment ensues, and there's an update on the purchase table. Now, the thing I was thinking about was, because this is, if you think of cases where you have a huge event, you can run into issues handling multiple users, right?
Hmm.
Ideally, the ideal condition for us would be person A checks to see if a seat is free, and then the seat's free, and confirms the purchase and has the tickets for that seat. And then person
Hmm.
B comes later on, is checking, sees that if the seat's free and it's not free,
Mm.
and this and the seat looks taken, so person B just looks for another seat. Fortunately, that's usually not the case, especially as you thinking of those bigger events where you have
Yeah.
a lot of people going for maybe one specific seat,
Yeah.
and
Yeah.
you run into a race condition there. So
Yeah.
yeah, so I think there are four race conditions when we think about this. The first one is kind of the a read modify Right. And in that, multiple users will want to purchase the same seat, but and the system must perform like a read write operation to
Hmm.
see to update the seat's availability status. And this involves checking if the seat's available, marking it as booked, and then storing that booking information.
Hmm.
Right. And then the second one is simultaneous request. And I remember in when I was in college, I went to University of Virginia, and we were like a huge basketball team and
Mm.
school. And every time Duke University would come over, I could never get a seat. I would have to sit there and refresh all day. And then one time it would say the ticket's available. I'll go through, click it, verify my card. Whoops, my card isn't here. Go, bring my
Oh,
card, finally put it in, click purchase, and then it says the seat's unavailable. And
yeah.
yeah, and that can be very frustrating. So in this case, for the simultaneous request, if two users submit a purchase request almost at the same time,
Hmm.
the system, may not have completed the first person's reservation before processing the second one's request.
Yeah. Yeah.
And then, so that's the simultaneous request. Uh, and then the third, which you hear often with these, is concurrency. So
Okay.
since the operations of doing this, like I was saying, all these multiple steps on atomic, essentially that's the word, which instead they consist of multiple steps. It's possible for both requests to check the seat's availability and find it available, even though it's only available for one user.
Yeah.
So yeah, I'm trying to run all the other. Okay, so we have that, and then I would say, and then the final one would be double booking, which is a big no-no. You don't want to turn up to an event, which has happened quite a bit to me sometimes, and you have the
On
same.
Ticketmaster?
It was it Ticketmaster. It was something close. Oh no, you know what? It was AMC. I think I was opening night to go see the Spider-Man movie, and
Yeah. Yeah.
yeah, somehow there must have been like a delay because I bought it online and someone bought it at the movie theater, which I don't even know how they were able to get on opening night, but somehow it was
That's
posted.
messed up.
In the end, I did get a one of those like the disabled seats, so it was a little nicer, I guess, because they pushed me. There was no,
God.
but
Okay.
it was decent. So
Yeah.
anyway, so double booking can also be a common issue. Uh,
Hmm.
so we'd have to think of ways to mitigate those risks. And one thing I can think of is one we would have to ensure that there's data consistency. So if
Hmm.
a transaction fails at any step, what we talked about, it'll roll back and prevent the seat from even getting booked. And that has to be consistent. And then also something that guarantees the atomicity. So I think it's a word. Where multiple users cannot concurrently modify the same seat in
Hmm.
a way that leads to the double booking. So one way we can do that, I was thinking, would be an ACID base, an ACID database, where we have transactions that are sequenced, and one or more SQL operations are treated as one single unit of work.
Yeah.
So that when they are executed, they either all pass or fail. We don't want either or. And
Yeah.
in context of booking a seat, a transaction um, might and probably should include check-in seat availability, reserving the seat, and then record the booking. So there are like one asset database to think of is Postgres.
Yeah.
That would work pretty well. The trade-off with this, though, is that we have to be mindful of deadlocks, right? Because poorly
Hmm.
managed transactions would lead to that, where two or more transactions are waiting indefinitely, and then you'd have a seat which is available to no one.
Okay.
Cool. So that's one thing. But then I think a second solution that can be coupled with this. Um, I think we said so. I said there's graphs. This sorry. The second one would be optimistic locking, and
Mm.
the way that works is it will rely on either a version number or a timestamp associated with the seat at which point it had been reserved. So when a user attempts to book a seat, the system checks the seat versional's timestamp before confirming the booking. If another user
Okay.
has already booked the seat, or no, updated this version of timestamp, the system can detect whether if there's a conflict and ultimately reject that action.
Yeah.
Cool. So is there any trade-offs for that? Honestly, the only thing is probably annoyance. Like I was saying, if a user they may need to try to redo their booking if there's a conflict, and if they end up if you're the unlucky person that keeps getting the conflict, you can get
Yeah.
frustrated after a while.
Yeah. Yeah.
So
I guess that's the trade-off that you're making here.
yes, so that's a trade-off I'm making. So to actually implement that in the database here, what we can do here is in, I guess, in the seat right here, we have it's available or not. That will not be able to tell us, if it's been reserved right now.
Hmm.
So what we can do is we can change this to a status. So we have seat status, and this would be an int, and essentially seat status would be if it's, let's say, if it's one, then the seat's available,
Okay.
right? If it's, oh, sorry, zero. If it's one, it's reserved, and then if it's two, um, it's purchased. Yeah. Um, Now, oh, and then let's see, there was one. Oh, yeah, and then we can also add here a insert a row below. Okay, I just click enter. Um, we can implement either versioning or a timestamp. I think for this, we'll just go for a timestamp here. Um, so, and ideally, we'll need both of these because the
Hmm.
timestamp will let us know if it's been reserved. The status will
Yeah.
actually let us know if it's available or not. Um, yeah, I'm thinking because we'll still have to enforce it. So that logic, thinking. So okay, I have two things. So the first thing we could do is we can frequently go through the seat table and find all the
Hmm.
entries where seat status is equal to one and selection time is, oh, and let's say you can reserve a ticket for 10 minutes, right?
Okay.
And let's say the selection time is greater than 10 minutes. If that condition is met, then what would happen is we can reset both the seat status to zero, so it's available again, and then just reset that timestamp to null.
Okay.
The only thing, because as you can see, I don't know if you noticed, but I like to go a little fast. So a trade off there, I think I might want to do is instead of doing all that, though it makes a really tidy database because it's always on point. There's the extra overhead of scanning
Mm.
queries and
Hmm.
updates. So instead, we could just say change that logic to if a seat status is equal to zero, or seat status is equal to one, and selection time is greater than 10, then we can allow the user to modify the
Yeah.
seat. So that way you're getting rid
Yeah.
of the overhead entirely for that.
Got it. Okay. I
Cool.
think this looks good. Do you have any, how do you want to wrap up?
Cool. I can go ahead and do the like kind of what the overall database, the whole system should
Sounds
look
good.
like. Okay.
Yeah.
Cool. Okay. So yay, time to put this into drawing. Okay. So let's just say here we have a user, and yeah, one thing that I didn't bring up because we kind of ran out of time is uh, well, since you have a lot of like traffic coming in, we'll want to include a something that can distribute the traffic. So in
Yeah.
this case, we can use a you know AWS like Elastic Load Balancer, and that will just allow us like any if even the traffic to come through, it can distribute to whatever servers, and that can be done through consistent hashing,
Yeah.
the
Yeah.
round robin. But yeah, I think that just and then uh, since I want to maybe just keep it, AWS, uh, we could EC2 is a great tool for auto scaling. So it would be able to, if you think of this, we don't know how many traffic coming up, but we need enough service to kind of carry the load. So
Yeah.
EC2 would allow that bringing up service kind of on the fly.
Okay.
So cool. So once we have that, uh, we'll have the different service up here. So we have web server here. And yeah, something I didn't get to, but we one thing to optimize the database, which we said we
Hmm.
progress, would be using a cache to get the most popular requests. So in this case, it would be
Okay.
events most frequently used, and making sure that cache is also
Most
updated too.
Got it. Like the most frequently visited events that people are
Yes,
searching up. Got
correct.
it.
And then also one more thing I won't be able to share here, but I can say it whilst I'm doing this, is
Hmm.
also optimizing the to optimize the database too. We could have a index to help querying, so that we can like kind of get the most frequently, like if a user's we getting the same sort of query frequently, a user an index can be used to help that query
Yeah.
run quick. Um, you know,
Okay.
and see trade-offs with that, you have to be very selective because queries make indexes take space to do as well. Oop, so cool. Do that here. And then, oh yeah, we said that we were going to have a Postgres, and yeah, this would have replicas to for reading,
Hmm.
and yeah, let me Yeah. Okay. I imagine there's an arrow coming to that one too. Um, yeah. And, and then one last thing I did want to mention too. Um,
Hmm.
there is one thing we spoke about earlier was that we for those popular events, there are going to be a lot of um, like uh, read and writing traffic coming through.
Yeah.
So it would be important um, to have a to make sure that we had something on like it's that's about 1,600 requests per second coming in at peak loads.
Hmm.
So it it would be like important. I'm thinking of the like backups for the database. So we have to, and also including a RAM, I would say, because looking at what we had, it's not a very they're not very huge tables.
Okay.
So we can use the as the Postgres database, but also fit all the data in a SSD and
Okay.
an SD card for that, and then we can even like go as far as to add a RAM and set that data in periodically. Now you may be
Got it.
wondering,
Okay.
yeah, is that RAM going to be fast enough? Well, like I said,
Mm,
it's going to need 1,600 operations,
yeah.
and a general purpose RAM would take about 3,000 input output operations, but a specialized one could
Yeah.
take 30,000. So I think we'll be good on that front.
To have that part of your system.
Yes, and then one last thing, RAM is volatile. So if
Yeah.
you lose the power, you like lost everything. So I think
Yeah.
it may be good to also add a uninterruptible power source there to power supply,
Got it.
so that it
Okay.
once it's down, it still has a couple of minutes to put everything in.
Yeah. Yeah.
Yeah,
If we ever move our general elections, political elections online, I feel like Ticketmaster should probably take a stab at designing that
that would be interesting.
because it is just as important.
Right. Yeah.
Yeah.
Um. Cool.
Thank you so much, Sam. It's a very complex system, so thanks for working through all the details. How do you feel, and do you have any thoughts or recommendations, suggestions to give to people who come across a question like this?
Yeah. Sure. So as you can see, like, it's very easy for a person to get kind of engulfed in, or like have a specific trail of thought going into a program like this because there's a lot you can talk about. Um,
Yeah,
and sometimes you feel like, oh, I haven't talked enough about this specific thing. But sometimes the interviewer will tell you, ask you specific questions about the specific part, and you just need to
yeah,
go more in it because they want to focus on it. And it also depends on the role you're applying for. For example, if I wasn't more for a security role, I'd probably talk more about how I would deal with, the I said I separated the payment security part of that.
hmm hmm
Also, if it was something that had to deal with customer satisfaction, which is something that a lot of companies go for, I may have introduced something like website socketing, or probably most likely long polling, so that users
hmm
can know, if they're waiting in line, where they are. And then one more
yeah,
thing,
yeah,
could have talked about message queues because that's something that also helps with a huge system like this. So it can be easy to
yeah,
get, like saying, overwhelmed with this, but your trail of thought, having talking with your interviewer is pretty. Yeah, just kind of go with the flow because I mean, they interviewers want you to succeed too, and
yeah, yeah,
you and I had a little bit of laughter here and there And
Yeah, your
yeah,
interviewer is potentially someone who you're going to be working with. So treat this like a problem that you're going to be solving with a coworker, honestly. I think that some of the most successful interviews that I've seen are the ones that feel the most like a working relationship with a coworker. And that it gives you a peek into what it's going to be like with this other person in the office. So keep that in mind. Yeah. Thank you so much, Sam. This was great. A very, very simple product in its functionality, not at all simple in its implementation. So thank you very much for walking us through that. I really appreciate it.
thank you very
And good luck with everyone who's watching at home with all your interviews.